So now I'm going to give you a few tips on the next set of questions. So 1 through 8, and these are the ones that some of you did some of these on the board and you got stamps. So if you got stamps, that's great. I'm going to try to make an online submission for this, just to first of all test it out, and second of all, it's just maybe a little bit easier way to submit these proofs. And so anyway, so look for that. And like I said, I'm in the process, so we'll see. If worse comes to worse, we'll just do the PDFs. And if you have the stamps, you can just submit the stamps in the PDF, and I can see those. Okay. All right. So number 1. So we're given 2 parallel lines here, 2 sets of parallel lines. And so remember that if we have these pairs of lines that are parallel here, right here, here, and here, here, remember that these don't correspond with each other, okay? Because they're not cut by the same transversal, right? They're 2 separate scenarios. And so if we're trying to prove that angle 2 is congruent with angle 12, we can't do that directly, right? We don't have anything for that, all right, directly, right? What we'll have to do is we'll have to say, okay, well, this set relates with this set, right? And then this set relates with this set. And so we can use that and some transitive work or substitution to say that, okay, well, I can see that they relate with one another, okay? Or you could do it with this one, right? So so you have options there. So so that's what I would recommend that you do. So just be careful. Watch out that you don't somehow relate these with one another directly, nor that you relate these with one another directly. Okay, so watch out for those. All right, number 2. So here we're given that KL is perpendicular to JM. We're given that KL bisects PLQ, right? And so remember, first of all, when you're given a perpendicular, you want to use probably definition of perpendicular to say that these are right angles, okay? And so that's something that you're going to use when you see bisects. That means you're usually going to say, okay, well, the definition of bisector says that these angles are congruent, and so forth, right? Now, this is actually, I just did a proof, and it took me 10 steps. So there's a lot of things that you might think are obvious that you have to really hash out on this one, okay? So for example, we know that these angles are congruent by definition of bisector, but we have to say, we have to use definition of congruence to say that they are, that the measures are equal to one another. And the reason we have to do that is because we're going to use the segment addition postulate to say that this angle and this angle add up to this angle, right? And you can do the same thing over here. And then the segment addition postulate uses their measures. And you want the measures anyway because you want to be able to use substitution property of equality and things like that, and subtraction property of equality. And so you're going to basically do that and set this sum equal to this sum. And then you can use some subtraction as well as, the angles that you prove to be congruent to get down to this right here, okay? And you'll get down to measure of PLJ is equal to the measure of QLM, and then you'll have to use the definition of congruence to put them back into the angles and congruent, okay? All right, so yeah, there's a lot there. Like I said, 10 steps, and so you're gonna use, like I said, definition of perpendicular, definition of right angle to get them to measures. You'll use definition of bisector, definition of congruence a couple times at least. You'll use the angle addition postulate for a couple different sets of angles. Use some substitution and some subtraction property, and So yeah, this has a lot in it. So let me know if you have any questions. I don't want to give it all away, but I've given you, I think, a lot for this one so far.